Hello everyone. Today we're going to be looking at this question from a 1995 IBHL math paper. It's a pretty spicy question about the binomial series given some integer exponent. So the constant terms in first the expansion of px cubed plus q over x cubed to the power of 8 and px squared plus q over x squared to the power of 4 are equal. Both p and q are greater than 0. So express p in terms of q. This is the key part of the question. This is what they're asking us to do. Alright, so things we can see immediately. We are looking at the constant terms. So a short, quick, intuitive way, snappy, to get to this constant term would of course be that, for example, in this power of 8, there are 9 terms, and given that the first term will have some x to the power of 3 times 8, 24, and the last term is x to the power of negative 24, I'm guessing the x to the power of 0 will be the fifth term in the middle, where we have px cubed to the power of 4 and q over x cubed to the power of 4 to get something like 8 choose 4 pq. And in this one as well, this would be something like 4 choose 2 pq. And they would be equal to each other, or something along those lines, which is why I want to, so this is the bet I'm placing, basically, that it's the fifth term here and it's the third term here, because it's the middle of all the terms of the binomial series, where it's the constant, because at one end it's 24 and at the other end it's minus 24, and especially for this one, at one end it's 8 and at the other end it's minus 8. So one important principle that you can note is that the powers of x in a binomial series, assuming that the power of here is some unchanging number, it can't be x to the power of x, but you get what I mean. The powers of x in a binomial series, assuming it takes the form something x to the, like ax to the b plus cx to the d, if it's something along those lines, the powers of x in a binomial series will form an arithmetic sequence. And the common difference will be the amount of factors of x that you lose by not multiplying by one of these, times, and then you add the amount of factors of x you gain by multiplying by one of these instead, right? So the way that I would suggest you go about it, if you want to be very methodical and one track, one mind about it, like you just want a guaranteed way out of the question, you should try and find the general term formula for a series. So you may recall something like n choose r times a to the n minus r b to the r for a nth term in a binomial expansion. So for example, for the first expansion, the nth term of this thing would be 8 choose n, and then a in this case is px cubed to the power of 8 minus n, and then qx to the negative 3, because it's over x cubed, times n. And what you want to do with this thing to make it useful to you is put all the real numbers on one side, and then it would be multiplied by x to the power of some linear expression, some an plus b. So here we have 8 choose n. We're going to factorize out the p to the power of 8 minus n. And we're also going to factor out the q to the power of n. And finally, we're left with x cubed times 8 minus n. So if you recall your indices rules, x to the power of a to the power of b is equivalent to x to the power of a times b. So in this case, x cubed to the power of 8 minus n will be x to the power of 24 minus 3n. And here, for example, x to the negative 3 to the power of n will be x to the minus 3n. Or overall, the nth term of this will be 8 choose n, p to the 8 minus n, q to the n, times x to the power of 24 minus 6n. So the way we got from here to here is just finding the general term, and we put all the numbers on one side and just x to the power of something on the other side of the expression. So what do we do from here? Well, if we go back to my bet, it was the fifth term of this. So in the terms, this would be n equals 4 because n starts at 0 and ends at 8 here. And for example, this term, the third term, is n is 2 because n starts at 0 and ends at 4 in this case. Anyway, we want 24 minus 6n to be equal to 0 because that's the exponent on x when we are looking at the constant term. And this would mean that n is equal to 4, like my intuition suggested. So constant terms, if, for example, it's x to the a plus something over x to the a, it'll be in the middle. The constant term will be in the middle. And you should be able to quite intuitively figure out what numbers of each term, how many factors of each term will create a constant term, so you don't have to go through this algebra stuff, right? So anyway, the constant terms in the expansions of these are equal, so let's just try and find the constant term, the n is 4 term for this first expansion, and then we'll attack the second expansion. So this constant term will be 8 choose 4 times p to the power of 8 minus 4 is 4 times q to the power of 4. And 8 choose 4, if I'm not mistaken, we can do some little calculation up here. 8 times 7 times 6 times 5 over 4 times 3 times 2 times 1. This is the manual way of going about 8 choose something. The dehumidifier has just come on, please wait. So the way you get 8 choose something, it's the first n numbers from 8 up here, and the first n numbers from 1 down here. So 8, 7, 6, 5, that's counting 4 numbers down, and 1, 2, 3, 4, counting 4 numbers up, is how you get, for example, 8 choose 4. So these two cancel out, and 3 cancels with 6 to get 7 times 2 times 5, which is 14 times 5, which is 70. Or rather, I could have gone 2 times 5 is 10, 10 times 7 is 70. Anyway, 8 choose 4 is 70. So the constant term for the first expansion is 70 p to the power of 4, q to the power of 4. Now, if we look at the second set of brackets, my bet was that the n equals 2 term is the constant term, because the power up here is equal to the negative of the power here, because this is qx negative 2 and this is px 2. So since they are sort of canceling each other out, and the first power of x would be 8, the last would be negative 8, and it's an arithmetic series, it must be in the middle where x is 0. So we can confirm this algebraically, but I'm just saying the intuition tells you that it's going to be the middle term, the n is 2 term. So to confirm this algebraically, our solid guaranteed solution is, again, to find the general term formula in this form, where we have all the numbers on one side and then x to some linear exponent in terms of n. Alright, so let's start working at this. The nth term of, what is this, px squared plus qx negative 2 to the power of 4 is 4 choose n px squared to the power of 4 minus n qx to the negative 2 to the power of n. And we can firstly factorize the p times 4 to the n, p to the power of 4 minus n out, and also q to the power of n out. And then x squared to the power of 4 minus n, you do the multiplication, you get x to the 8 minus 2n. And here, x to the power of minus 2 to the power of n is x to the power of minus 2 times n, so x to the minus 2n. And we are left with, if we push all the numbers to one side and we multiply these exponents, we add the exponents together, we'll get that the nth term is 4 choose n, p to the 4 minus n, q to the n, over, not over, but multiplied by x to the power of 8 minus 4n. So, where do we go from here? 8 minus 4n is the exponent of x on the nth term, and we want it to be 0 to get the constant term. Now remember, the intuition tells us, again, that n will be equal to 2. The middle term is where the constant term will be, because the first term and last term have the negative exponent of each other. The first term is x to the power of 8, while the last term is x to the power of negative 8. And the powers of x in a binomial series will form an arithmetic sequence when it's something like this. So that's how you figure it out. So 8 to the minus 4n is 0, and this will get us n is 2, as the intuition tells us again. So this means that our constant term will be 4 choose 2, and this, I believe, is a low enough number that you can just use Pascal's triangle. It should be like 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1. Yep, 6 is the number we're looking for. Times p to the 4 minus n is 2, and q to the n is 2. So the constant term is 6p squared q squared. Now, we are knowing that p and q are both positive, and we want to express p in terms of q. We have one equation, which is why they're asking us to express one in terms of the other, rather than solving for the values. And our one equation is that this constant term, 70p4q4, is equal to this constant term, 6p squared q squared. So from here, it should be just some algebra. So 70p to the 4 q to the 4 is 6p squared q squared. Well, the first thing we can do is cancel out p squared q squared from both sides. So this is gotten rid of, this is gotten rid of. The exponents decrease to 2 here because we're removing 2 p factors and 2 q factors from this side, or both sides actually, and we're deleting this factor here. So we get 70p squared q squared is 6. And you remember we want p in terms of q, so it will be p equals something something q. We need p to be the subject of this equation, so p squared q squared is 6 over 70, or p squared is 6 over 70 q squared. And we can square root both sides, and since we know p and q are positive, we can ignore the fact that it could be plus or minus in a normal situation. So p is root 6 over q root 70. And you'll want to rationalize the denominator such that p is root 420 over 70q. And further on from this, you might be able to get 420 into some more roots. It's 21 times 20, 3 times 7 times 2 times 2 times 5. Yep, we can get rid of a 4 from there. So it's 2 root 21 times 5. It's 2 root 105 over 70q, which we cancel out the 2 and the 70. We get 35q as the denominator. And our final answer is P is equal to 2 root 105 over 30q. I do not have the mark scheme for this paper, but all the arithmetic steps that I made should be correct. If you have any corrections to make, please leave them in the comments. Same as if you have any suggestions for future videos. Thanks for watching.